Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Solving Problems with 2 Unit Rates. Alright, let's take a look at number 1 here. Julie's car averages 28.8 miles per gallon of gasoline. If she pays $3.02 per gallon for gasoline, how much will it cost her to travel 192 miles? Alright, so there's something I want you to notice right here. The first sentence gives you a unit rate. But the second sentence gives you another unit rate. And you might notice both of these unit rates are something per gallon. So there is a bit of commonality here. They're both dealing with multiplying by gallons. Now, we've learned that we can write an algebraic equation to represent a proportional relationship when we have the unit rate. So, for example, per gallon means times the gallons. So we can take 28.8 times the gallons to equal the amount of miles. We also can say that $30.02 per gallon would be 3.02 times the number of gallons to equals the price that we end up paying for the gasoline. Now, what are we given here at the end? It says, how much will it cost her to travel 192 miles? Well, that obviously can't be used in this equation. This equation over here on the right has P for price, that we pay for the gasoline, and G for gallons. We have 192 miles, and before I can answer this question, how much will it cost? Cost would be the price right here, but I need to get the gallons before I can get that price. So, I'm going to have to start with this equation over here, put these miles in for the M, and then solve for the gallons. Once I have the answer for G, the number of gallons, then I can put that over here in this second equation and use that to get the price. So it's a two-part problem, 2 different unit rates, 2 different equations that I'm going to have to use here. So I hope you're writing this down with me. 192 miles, let's put that in for the miles, equals 28.8 gallons. To solve for the gallons, since it's not by itself, we have to do the inverse. Inverse multiplication is division. So we're going to divide on both sides by 28.8. Calculator time. This is going to give you 6.6 repeating. Now, it's not really helpful to put a repeating decimal in for a variable. That's kind of annoying and hard to do in a calculator. So I would recommend that you make its mixed number form instead. Now, you will eventually have this memorized that 1/3 is 0.3 repeating and 2/3 is 0.6 repeating. You might not have it memorized yet, but eventually you will, because these are very common repeating decimals. So the 6 and 2/3, this is definitely going to be the better option for placing this in for the G in this second equation. Because again, what am I trying to find? I'm trying to find how much will it cost her to travel 192 miles. But before I could get that, I had to find the gallons used in 192 miles. Well, I now know those gallons. So substitute that in, mixed number form instead of repeating decimal form, in for the G, and now we're solving for the price, a variable that is already by itself. So no inverse operations this time. We're going to just multiply. 3.02 times 6 and 2/3. You could use your calculator to do this, and you will get about $20.13 when you round to the nearest cent. All right, do we have all of that written down? Because now that I have made sure that you wrote that down, I want to point out you could have done this in a shortcut method. Over on the right side, wherever you have room, write down there basically was a shortcut. Since we had miles per gallon and we had the miles traveled, but we didn't know the gallons, we could divide the total miles by the unit rate of the miles per gallon, and that will leave us with the gallons. I know, same answers we already saw, but write this down. Much shorter way of showing work. And then $3.02 per gallon means times the gallons. So you could take $3.02 times the 6 and 2/3 gallons, and you get $20.13. You're like, Mr. Underkoffler, why didn't you just show me that first? Well, because I wanted you to understand why we were dividing and why we were multiplying here and not dividing both times or multiplying both times. And the best way that I could explain that is to use what you've already learned with setting up algebraic equations when there is a unit rate. So that's why I showed you this method first. But now that we've seen it, now we can understand this shortcut method. And yes, from here, using the shortcut is totally fine with me. So why don't you go ahead, hit pause, try just number 2. Don't even go to 3, 4, and 5 yet. Just try number 2 right now on your own. Hit pause and then hit play to see how you did. Okay, have you already done problem number 2? You probably noticed we have 2 unit rates again. We have 500 feet per minute, and then we have 15 calories that are burned per minute. What are we asked to find? I'm going to underline this. About how many calories will she burn from running 10,560 feet? Now, yes, that is 2 miles. So if you thought this was a weird number, 10,560 miles, it's not a weird number. It's actually exactly 2 miles. But since this was feet per minute, I don't really want to use the miles here. I got to stay consistent with my unit of length here that we're running. So feet and feet, that's staying consistent. All right, we want to eventually find out how many calories are burned. We know it's 15 calories per minute, but we don't know the number of minutes. But we know it's 500 feet per minute, and we know the total number of feet. So, shortcut, you can divide the total amount of feet by the unit rate of how many feet you can run per minute. And when you do that, the feet divided by feet basically will cancel themselves out. You're left with the minutes. And that's going to go ahead and give you 21.12 minutes. I know that sounds really weird. Please do not round it. We are not done yet. We now need to take the fact that she burns 15 calories per minute. We now know the minutes. So now we can find how many calories she's going to burn. Per minute means times the minutes, and we know that number. So 15 times 21.12 is going to give you, well, it did say round to the nearest whole number. So I rounded it to the nearest whole number. You might not be aware of this, but normally calories are always expressed as a whole number. That's just the way it is in real life. So that's why the directions said round to the nearest whole number. So there you go. Now, if you wanted to use the equations method like I initially showed you on number 1, you could. That would be fine. All right. There are 3 more problems left to go. Number 3, number 4, number 5. They do get slightly more complicated as you go. So let's see if you're up for the challenge. 3, I don't think you're going to have too much of a problem with, even though it's a little wordy. 4, I have faith you can get this one. And then, definitely number 5 is the challenge problem. This is on the back side of your page. Try it as best as you can and see if you can get it right. I think you actually have a good shot here. So hit pause, try 3, 4, and 5, and then hit play once you're done with those problems and you're ready to check your work. Okay, have you already done 3, 4, and 5? If not, hit pause now. You got to do these problems on your own. Okay, so we are trying to find on problem number 3. How much money should you expect that she's going to spend in the fall semester for math tutoring? We know it's $40 per hour, but we don't know the hours. What we do know is that on average, she's doing 12 math problems each hour. That's like saying per hour, and we know the total number of math problems from the fall semester. So take the total number of math problems, divide by the unit rate of 12 math problems per hour, and that will leave you with the number of hours. And conveniently, this was a nice 19 3/4 hour. Not quite a whole number, but a nice decimal that we can understand. That's 3/4. All right, now we can take the $40 per hour and multiply it times this amount. Normally, tutoring would be full hours only, but this was already clarified here in the second sentence that this tutor is flexible and allows things to be a little bit longer or a little bit less than a full hour. So we're not going to round this. Keep it 19.75. And that's going to give you $790 that we would expect that she spent in the fall semester for math tutoring based on the information that we were given in this story. All right, problem number 4. We got 16 ounces in each pound. We are also told that each burger is going to use 5 ounces of ground beef in each burger patty. that Greg's doing for this outdoor party. And then we are also told another unit rate. So this is like 3 unit rates here. The cost for only being sold in 1 pound packages is $6.49 per pound. And we need to know, how much will Greg spend for enough ground beef to make 25 burgers? Okay, what in the world can I do with this? Well, I know that each burger is going to use 5 ounces, and I know that I need 25 burgers. So 25 times 5, you would not divide here. You're trying to find how many ounces does Greg need. And we know that each burger is 5 ounces. So that's like saying 5 ounces per burger. We know the burgers. So 25 times 5, 5 times 25 means 125 ounces of beef that Greg needs. Now, the cost is the cost per pound. I can't multiply that by ounces until I convert, which is why the first sentence tells you that there's 16 ounces in each pound with that, which I bet a lot of you already knew. So we're going to take 125 divided by 16 to find the number of pounds. 7.8125 pounds. Having said that, since the problem said that the grocery store is only selling the ground beef in 1 pound packages only, then we need to actually round this up to the nearest whole number. And by the way, if you were doing this in real life, if you were Greg planning for the party, it's better to have more than enough beef than not enough beef. You could always put a little bit extra, maybe 1 ounce or whatever, something like that, in each patty. So having a little bit more than you need is actually very logical. So we know that he's going to have to buy 8 pounds of ground beef. Now, the question is, how much will Greg spend? That's money. We now know the pounds, 8 pounds. We can multiply it by the unit price of $6.49 per pound, and boom, finally got our answer of $51.92. And the challenge problem of the entire packet of guided notes. This is actually harder than what we're going to have in our test, but I wanted to give it to you anyway to see if you could deal with this. We have 2 different people involved. We have a graph for Tracy. We do not have a graph for Kelly. Kelly's information is given to us here in this part right here, averaging 36 miles per gallon, and the gas station is going to charge $3.45 per gallon, where Kelly's getting her gas, but Tracy's is a different cost. The question is, who's going to pay less for their weekend trip, and how much less will they pay than the other person? So here's the key information. We know each of them will drive 180 miles. Well, it just so happens on Tracy's graph, here is the 180. What we don't know is how many gallons Tracy's going to use. Although, wait a minute, can't we get that? If you look at this graph, you'll see the 180 is right here at this point, and that is where the gallons of gasoline is 6 gallons. All right, so let's start separating our work. We got Tracy, we got Kelly. From the graph, we know that for 180 miles, Tracy is going to use 6 gallons of gas. You don't have to write all that out, but that's the information that we can actually get from this graph. We know that Tracy's spending $3.15 per gallon, so we can multiply that times the gallons that we got from the graph. And that's going to tell you that Tracy is going to spend $18.90 for her drive of 180 miles. Now, what about Kelly? We don't know how many gallons she's going to use, but kind of like the problems we had on the front side of the guided notes, we can divide the total miles that she drives by the miles per gallon to get the amount of gallons. So if you take 180 divided by 36, you're going to find out that Kelly is going to use 5 gallons. Now you can multiply that times her price of $3.45 per gallon, which means $3.45 times the 5 gallons that we just found out from dividing. $3.45 times 5 gives you $17.25. To answer the question, who is going to pay less and how much less? Well, I think we can see that Kelly is definitely going to pay less, And if you do some simple subtraction here, you will find out she pays $1.65 less than Tracy would. And that concludes the guided notes on solving problems with 2-unit rates. Again, this last problem was more complex than what we're going to see in our test, but I thought it was still a good challenge, make you think problem for you to try. All right, thanks for watching. We'll see you next time.